on Twitch. And
Yeah.
at some point, I was on a page where they explained. Sorry. Here we go. Cool. Yes. We're live.
Fantastic.
Cool. Okay. So last time we got really into the weeds
Yeah.
with images and what the image is and how to most inefficiently represent an image. But maybe mathematically interesting, and yeah, actually, like Keegan sent me a video after about shaders, and I only watched like the first like few minutes, and there was something interesting. But maybe Keegan, you want to talk about it? If you don't, I will take over. But
So I also didn't watch too much of the video because like he spoke a bit about what he was going to do, and then he spoke a while about like getting his build system to work.
yeah,
So,
it's like
but like
That's
the
the fun
idea,
part.
yeah, I mean, he built like his own like build system for C, and it's basically like a C file that he uses. It's pretty cool. But anyway, so he was basically speaking about like what we were doing. We basically have a function that maps coordinates to a color, and then when you want to render something, you just query. Well, you go through order the coordinates and then query the function to say, "Oh, what color should it be at this point?" And what he did was he wrote like a little DSL or grammar for like a small language for like a program that represents that function. And basically what he did, he just like randomly generated that AST, and then you get like these pretty cool like pictures that come out of it. And yeah, that's about what I what I watched from the video. But I thought it was pretty interesting. And then I think he spoke in that video about wanting to then compile that to GLSL or some shader. And I don't know if he got to it, but I thought that was pretty interesting. If we could maybe do that, because apparently Raylib like provides you an interface into that, and all you have to do is just give it the file, and it'll just run it on the GPU for you. Because right now we're doing like software rendering ish, where like we're telling like the CPU what to do, and then it's like interfacing with GLSL, and then it's running it instead of like it being a shade and actually running on the GPU.
Okay, before we continue down the path, hello, Fernando.
Hello.
I'm Fernando Aon from last time. Can you hear me?
Yes.
Nice to meet you.
Okay, well, pleasure to meet you finally.
Yes.
Yeah. I'm sorry I joined a bit late. I was figuring out things with audio. What did I miss?
Well, yeah, we were just discussing this video we watched. Well, yeah, I'll just give my interpretation of the video, and then that will kind of catch you up as well. Yeah, so we were like last time we were discussing this, what an image is, which we kind of stole from Connell Elliott, which is a function from location to color, or location to actually any type. Because if it's a bool, then it's kind of mapping a region, and if it's a color, it's an image. And then Keegan sent on this video about this other guy generating pictures and going to send these pictures to a shader, but the way he also represents an image is a function from a location to a color, which was cool to see. Behind his function is a whole context-free grammar that he uses to generate images. So you kind of specify your almost probabilistic context-free grammar. And then that generates like formulas for each that is mapped to each location, right? So every point only requires the coordinates to generate itself. Okay. Now on a CPU, this is pretty slow because then you for loop through everything and draw each pixel. But what he also mentioned is like, well, I'm pretty a noob to this whole shader thing, but what he mentioned is like a shader is basically something where you can tell the GPU, can you render each pixel from me, and like then it will use like do that all in parallel. It will do each pixel in parallel. So that's kind of, it has limited power in what it can do in parallel. Like, so you can't, you mentioned maybe you can't do any branching, but you can execute formulas in parallel. So that's a pretty interesting idea. And what's cool is it still uses our definition of location to color, which means I feel a bit more confident we're onto something that might not be super inefficient, and might be useful, and not just mathematically interesting. So that yeah, I'm a bit more optimistic after seeing that, but I'm not entirely convinced because I don't know exactly how it works. But yeah.
Okay, cool. Yeah. I mean, my understanding of shaders and shader languages is also just that it goes up to the you're computing the image per vertex, and there are some restrictions because you're not using the CPU, but I don't know much more than that. So yeah. We're in a good starting point, I guess.
So I think there's potential for like where we build a CPU renderer just because like it's might not be fun to on stream learn exactly how it works, but know that we can also build a GPU renderer later, and our definitions should be like the proofs should be the same. It's just what we render will be what we use to render the image will be different, and one is inefficient and one is efficient. But yeah, that's another way to see it. And then also like there could be this DSL we built for the shader that generates the shader code and then executes it.
So then we have something like a set of primitives that we use as an interface, and different implementations, one CPU, one GPU, and we just prove things onto interfaces. And then, okay, I see. Yeah, that's nice.
It's I'm not entirely, but like, yeah, the idea is still forming, but I think there's something there.
I think most of the complexity would be in that translation layer, and how constraining that is. Well, we'll have to figure out. We'll have to figure out once we actually start into the GSL thing. But I don't know. Cool.
Yeah, and I think it's also like someone last time on stream mentioned this do notation for the shader. Maybe it was you. I don't know.
Yeah.
Yeah.
I had like from a UI or from a programmer perspective, I think it would be nice. From a implementation perspective, I don't know how usable that is, because I mean I'm thinking of this as an effect, let's say, or like what you're constructing with do notation, an AST that then later you can translate that AST into GPU. And then I guess the awesome things like the if statements that I have to think through, like, okay, we have an if statement in the language, but we cannot have it when compiled. Then how do we handle having an if statement in a do block, let's say? It might be fine, but I don't know.
I think we'll probably have to do our own little DSL rather than a do notation, just to avoid that.
That makes sense, yeah.
Yeah, and only support what we actually can support. Like, if we find out we can support if, yeah, I don't know. Well, then we also have to show that the image is a monad, which I think it is, but I can't remember.
That is completely uncharted territory for me. So
Okay.
let's see, I guess.
Yeah. So I wonder, Paul, did you have anything in mind for today, or?
No.
Okay.
Sounds like a good plan.
Then I think what we can do today, which is like doable, is proofs for our image, like to show all, like it's a functor, it's like a lawful functor.
Yeah.
It's a lawful append, all of those things. And we can also do the alpha blending for the image. We can put in the proper formula, and we can actually try to draw something with this image, like in the most inefficient manner possible, but just to see how
to draw something. Yeah.
Yeah, to see how things work. Like maybe we start with drawing something,
Yeah.
because then it can be later cool to do proper alpha blending and then see like, oh, now this works.
See what it's not just the number.
Yeah.
It's not just a rational number or four rational numbers.
But let's start with the wrong implementation that we have right now.
Yeah. I
And
just want to post the link to the paper again,
cool.
because I think it says that it's well, it may have like monad, or I think it's applicative is the thing.
At least applicative, yeah.
Yeah. Oh, but trying to figure out where to post stuff is
Well, you can also
difficult.
just put it as a comment in your file. That's also fine.
Oh, that's a good point. I wanted to post it to the Twitch chat as well. Yeah, so it should be in the Zoom chat and the Twitch chat.
I'll put it in. Oh, there you did. Cool.
Yeah. Okay.
So I
right.
think,
So what does the render function look like?
Yeah. Yeah. So I think the render function takes like the width and height, I guess.
Yeah.
And then just for loops through each pixel and calls the image function.
Yes. So it takes the image of color. Yeah.
Yeah, we can just do this in IO for now, yeah. I think it's
sorry.
Yeah, switching
switching from Haskell to Lean now.
Yeah.
I write in Haskell all day. I can't switch between them very easily.
No, they're just too close.
Yeah. So we need to. How does this work? Because this is like scale somehow invariant, isn't it? The image doesn't know its bounds. So how does that work?
Well, wherever you call the image, right? It can always return, if we look at clear or something, or empty image.
Yeah.
Right. It can always return transparent.
Right.
Okay.
So So you have to, but when you're constructing the image, you have to sort of know where it's going to be displayed, because you could use like a million pixels by a million pixels, but you're only going to render 1,000 by 1,000 pixels in the middle.
Yeah.
So you sort of have to know what scale is when you start out.
Yeah, they are. You kind of need to know a few things, yes. But like, let's not make our render function scale. Let it just render.
Yeah.
Let's make it really stupid, and the person hooking up these functions need to make appropriate size decisions. But
yeah.
So do we have a draw pixel for Raylib? I think we need that
that's a good question.
puzzle piece first.
Yes. Bindings. So we need to just forward the draw pixel thingy.
Cool.
I didn't update the Raylib yet.
That's okay. We can just do it now. Would be a good demo. Like, I don't know how to do it, so it'd be nice to see how you do a function. Like,
so okay, so we can draw. We can pick either of these. So
okay.
probably a vector.
Okay.
Okay.
Yeah.
So everything needs to be in this format. So
okay.
you need to return one of these things.
Okay.
Clean obj res. Draw pixel. Pixel v. And then you get this vector2 thing gets passed in as another one of these lean object arguments. So so we should have like an example here of a vector. Yeah.
Cool.
And then again, like a color, it's the same thing.
There's one.
Here we go.
Yeah. Oh, okay.
Just for the names.
Yeah.
And then you have to convert them to Raylib vector2.
Okay.
This is the position. Then I just have like functions to convert them.
Okay, nice. So does it have to be called vector2arg, or can it like be?
No, it can be called something else.
So we can call it position, like.
Yeah. Position arg.
And then color arg, I guess, too.
Yeah.
Okay.
So then you just have
this
these.
Is purely for consistency. This is not used at all. Like, the positions of the arguments are used, but the names are not. Okay.
Yeah, so then you get so vector2 in the way we represent it in RayLean is with a pair of floats.
Okay.
So you need to say, give me the float at 0 offset, and then give me the float at double offset.
Okay.
And they get the lean.h gives you these functions for doing that.
Cool.
So this is how it works. Color arg. And then we have to think about whether these are borrowed or not. Whether we.
Okay.
And then we just draw the thing. Draw pixel v. Position. Color. Oh, sorry. Capital D for the RayLean ones.
Yeah.
And then we return this. We just return IO unit.
You mentioned we have to think about whether they're borrowed.
Yeah, so when we so I think in this case, because you're passing ownership of these things into this function.
Mm-hmm.
So some of them you have to worry about. You have to worry about whether you need to decrement like the, what is it called? The reference count.
Yeah.
I think in this case they just get. I think in this case we don't have to worry. Anyway, you'll find out because you'll just have a memory leak. So
Yeah, but that's not
then
our
depending on how because I was doing this with the orbital thing and I got one of these things wrong, and then it was using 100 gigabytes of RAM after a while, and it's like, oh well, you have a memory leak somewhere. And then
so is that how you taste it? You run it for 5 minutes and you
yes.
see. Excellent.
Well, I mean, there's you can try to figure it out as well, but so then I need to remember basic one of these. I can't even.
The graphics 2D one?
I just can't remember. I think it's in core. So you have to do the relevant extern thingies here.
Oh, okay.
So and this is what I mean about the borrowing here. So let's think of an example.
Well, I guess we're gonna pass the vector. So
yeah, we'll pass the vector.
That is the little symbol. So
draw pixel V. And then we pass a vector position, sorry. A color. We get units. Okay, so that should be it now. But do I need to do this or not?
That's not bad.
Probably.
Well, everyone does it.
Yeah, draw a line. Everyone does it. Okay, so I don't know. I can't remember the rule now. We can look it up in the docs.
I think it basically means you're in charge of freeing it, right?
I think yes, but what it means is that you borrowing it. So the thing is the thing inside here shouldn't mutate it. I think this function shouldn't mutate it, and then like there are some of them where you have to. Yeah, so for example, update camera. You pass, you get the camera back, and so it's not borrowed. So you're passing control of this camera to the function, and it gives you back a new one. So you don't hold on to it in the call. The caller doesn't own this anymore.
Okay.
So you don't use this anymore. Yeah.
These are like Rust borrowing rules?
Yeah, something like that. Yes. So you can look it up in the I'm probably doing a really bad job of explaining it, but if you look up the lean for FFI, it does a good job of explaining what this is somewhere. What was it? At 10%. Yeah, so this is where the word owned gets used, and I always get confused with this word. So all lean object parameters of external function are considered owned, i.e. the external code pass the virtual RC token is responsible for passing this token along to another consuming function or freeing it. Which use reference counting overhead parameters can be marked as borrowed. Borrowed objects must only be passed to other non-consuming functions or converted to owned values.
Yeah, okay. So that still means I'm borrowing it to C.
Yes.
But I'm in charge of freeing it.
Exactly.
Yeah, but if I don't
where this up, yeah.
Put that, then I'm pausing it to C and saying, I don't need this anymore. You better free it.
Yeah.
Okay.
So you see in like, hopefully you'll see this in the update.
It feels like the wrong default, like 100%. I would have done the exact opposite. Not have the symbols when I'm in charge.
Yeah, so you see here that you need to do some fiddling around here. So you has this, you can have this exclusive flag, in which case you don't need to decrement it, or maybe you shouldn't or something. I can't remember exactly now. But then I think you normally end up in this code path where we're basically constructing a new camera for use in the caller. And so we have to decrement the reference count on the thing that we were given, because we were, it's been incremented when it's passed to us. We need to decrement it to say that we've finished using it, and then you get the new object back. But I seem to recall you have to do this for some reason. Should have added a comment.
Interesting. Okay.
Yeah.
That's for next.
Okay. But anyway, yeah. Okay. Well, I don't think we'll get a memory leak here, basically.
Yeah. Okay. Well, let's
okay. So we should at least compile.
Yeah.
We should probably call this render function from within an example. So maybe in bouncing ball. So we should just, the render function could just call this.
Okay.
Yeah, I think that's right. How do we do this?
We have to
image
import it.
Yeah. Well, I guess it's part of RayLean. It's just, maybe it's just in scope because we didn't wrap this in a namespace. It might just. Okay. So we may want to. This is now ambiguous, right?
Yeah.
Yes.
Just to avoid the ambiguity.
Yeah. RayLean.
Raymage.
Raymage. Well, that should be because I've imported RayLean, so I should just be able to say RayLean. Oh, no. No,
RayLean.image.
Don't tell me I've already forgotten how this namespace thing works. I don't need to import it, do I?
Yeah, try that. Dot render.
No. Nope.
Oh
no, hold on a second. No, I thought this is how it worked.
Well, where is the file located as well?
Oh, it's in this one.
Yeah, where is that?
RayLean graphics 2D
image.
Oh, I need to import RayLean graphics 2D unless it's in. Oh yeah, this is not how it works, is it? So I need to put it in RayLean.lean. It's here. Graphics 2D image. Yeah, okay.
Yeah.
Oh, it's died.
Maybe try to compile now and see what error we get.
Yeah.
Oh, maybe that worked. No.
Bad import. Oh, because you need to probably. Oh, because you need to do this as well. What? It's not. I think I just got very confused about how the namespaces work.
Okay, well, what about just for like consistency? Make that namespace RayLean.graphics2d.image. and then everything lines up 100%.
Oh, right.
And then recompile.
Yeah.
Okay. Okay. What's wrong? Okay.
So graphics 2D bad import. So this. What is the difference? So do this not typo or anything?
Yeah, it doesn't seem like
Because this is not this is not related to the namespace. This should just be
we just
the
double
file
check?
name.
Can we just double check that this file actually compiles? Like if you go back to the compile errors.
Yeah. Oh, hold on. Yeah.
Just make sure that file is not in the list.
Oh, I see what you mean. Yeah, so it could be that graphics examples bouncing ball.
Up, I guess.
Some required builds. No, there's graphics 2D image.
Yeah, there it logged some failures, so maybe go up to find them.
RayLean graphics 2D. Cycle detected. There we go.
Okay. Okay.
Oh, because this imports RayLean. Of course, it can't do that. Why does it need to do that? Oh, it needs to import RayLean.types, I think.
Cool.
There we go. No.
Yeah.
Oh, there we go. It's back. Okay, so I think I'll just change it to that. Ball. LSP dead. LSP back. Nope. Application type mismatch. Yes, because we need to give it a we need to give it a width and a height.
Because do we know what this window is?
Yeah.
We
can just use the global variables.
Yeah. Cool.
We should need to give it an image.
Yeah, so I think we want a monochrome image.
Yeah.
With like.
Oh. Well, I'd like to do is qualified import of that, but I don't think I can.
Yeah, that's fine. Yeah.
Color.red. Okay. So that should fail. Yeah.
Cool.
It's going to crash. Oh yeah, it crashed.
There we go.
There we go.
Sorry.
Executed. Sorry.
Cool.
Okay. So so I want to do a nested for loop then on this thing.
Yeah.
So I do my id.run.
Well, I think you just do now because we're in IO.
I can just say that's true. So what is the syntax for this? Do I for M?
Good question.
So I'll do for the 4 or 4M I need to do here. Oh dear.
Yeah, I'm looking.
No, it's not 4M, is it? Because it's not. I'm not getting this from.
Okay.
I just want a for loop, don't I?
Yeah,
I don't remember the range syntax or anything.
yeah, it's pretty weird. I'm just hoping I find a better one, but I did. Oh, oh, okay.
Something like do conveniences.
I
Yeah.
got it. I got it. I got it.
So one
I'll
question,
post it to the Twitch chat.
why isn't it just for X in the range? Is it
Yeah,
because
yeah,
we're
that's
like
what
in a
we're
different
trying to
monad?
figure out. Trying to figure out what the syntax for that is.
Oh,
Yeah.
I
So
don't know
it's
myself.
this. Yeah.
I think so. And then like Python, yeah, like Python index syntax, but
And then
yeah.
I think then a one as well,
Do.
but maybe
Oh,
this
you
one.
need to put a 1 here.
Well, maybe not. Maybe not.
Yeah, yeah, yeah.
we'll figure it out.
Yeah.
We'll see.
Yeah. Cool.
Draw.
So she asks what IDE you are using.
Oh, this is Emacs.
Yeah. And
But I would recommend that you use VS Code.
yeah, it's easier to
because
get
I'm
started.
unable to use VS Code.
And then does it compound to shaders? Not today, maybe
No.
in a future episode, but not right now. For now, we're just trying to do the most basic thing, just draw a pixel, like do the stupid version of this image drawer, but we're hopeful in future we can create a shader version, but we don't know what we're talking about when it comes to shaders. So we are learning.
I think I need to really dot pixel v. Yes. Oh, I need to make a vector.
That's okay.
Oh, all my muscle memory's gone already.
Yeah, the weird carrot. Yeah.
Yes. Oh, because this needs to be a float.
Yeah.
Just gives me a float.
Cool.
And then I look at the image and I call it on. So I want to do let. Don't need to say let.
I don't think so.
Well, I want to use the because I'm doing this right. I'm drawing at this point and then calling I at P to give me the color.
I think.
Do I say in? No, no. Oh, you did. Sorry, I'm really not with it today.
Yeah.
Okay,
but,
there we go.
But I asks for, I think, rationals. So.
Okay. Interesting. Yep.
Yeah. Let's worry about that after we get it
Yes.
working. Like, let's not make it pretty.
Hopefully that's not a 2 wrap. No. Oh, I need to import. Okay, so we need to fix all this stuff because import batteries. Nah. I was hoping that.
Yeah. So.
Oh, sorry. Yeah, you can't do that.
I think you can construct a red with a net. Like it should be pretty.
But position, I don't remember what position is now. I thought position was position that doesn't position looks. No, but that should be okay. Oops.
Maybe it's red dot from net.
Yeah. It's complaining about the bring up the it's complaining about the constructor. So I'm not even sure that's. Let me just use that. Let me just use MK.
Maybe location dot MK.
Oh, it's location. Sorry. Yeah.
Cool.
Okay. See what it does.
Yeah.
Ah. I see nothing. It's not crashed.
It's not crashed either.
No.
Oh, it's just slow. It's just slow.
Oh, I see. Maybe it is rendering. Okay, so maybe we pick a smaller width and height.
Oh, wow, that's very slow. I mean, yeah, that's not good.
No, yeah.
Maybe we render something static.
Yeah, I think also pick a lower frame rate. I think that might
Good point.
help us.
Also, just out of curiosity, what width and height were we using?
Yeah, so we're using 800 by 600.
Okay.
So let's make it 8 by 6. Conservative.
Oh, you're still doing 120 frames a second.
Oh, okay. What?
Not even.
Why is it giving me the selector?
Because shouldn't you go to bouncing ball?
Yeah, it should go to bouncing ball.
Okay.
But I think I maybe just misspelled bouncing ball. All right, so I want to change this to 1 frame per second. I'm saying bouncing balls. Oh, we got the spinning beach ball of death.
We did.
Can't
see
that
it.
Good?
I don't think so.
No, come on. It's what?
Wow.
Okay, maybe we're doing something wrong then. So render.
How about we draw 1 pixel? Like,
okay,
it's a crazy idea.
Okay, well, maybe this.
Wow. Yeah, I don't think you need to call update anymore.
Yeah, I don't. Yeah, exactly. I don't need to call update. I don't need to call init. Well,
you sure you don't need to call init?
So init is just setting up this thing. Oh no, I do need to call init.
Yeah.
That's a bad choice.
But just but you can still uncomment update. I think that's comment. Sorry. Yeah. I feel like
hold on. Yeah, maybe that isn't working. Well, this we should do at least this, I think.
Okay.
Yeah, something fishy going on.
We can take the for loop out of our render.
Yeah.
I think it errored out. It said compilation exited. Oh, unless
I killed it. Yeah, I killed
it. Yeah.
Okay, so this code is not working at all. Okay, so this not. Maybe we should just start from scratch. Well, start with a start with a different example.
It's working.
Yeah, so it's not working in this because all I'm doing here is clearing background.
Yeah. Okay, make it bigger again and give us a larger frame.
Oh, sure. Yeah, that's true.
They just
Yeah, because it should just give me a white screen now.
Yeah.
Don't know. Yeah, something gone wrong.
Ooh. Because it was working. You were running this.
Yeah,
when
yeah,
we started
exactly. I
stream,
ran
so,
that earlier.
Yeah.
Okay, so init does.
Oh, wait. Can you go back to that render?
Yeah. Oh,
Because look at there. You say render frame.
oh gosh, I'm not calling
Yeah.
render frame.
Yeah. There we go.
No, but he shouldn't need to call render. Oh, I do need to call render frame.
Yeah. I think you call this render function.
Yeah,
I would rather
and then
just edit the render function.
okay, sure. I'm just
Then it's like it was
check.
before.
Yeah, okay.
Yeah. Cool.
Let's get back that out. We'll put this back.
Hmm.
And then get rid of these and get rid of update.
Yeah.
That should work.
Mm-hmm.
Okay, yeah. So before, I think like if you don't call begin and end on the drawing, I think it just like it's probably like undefined behavior or something like that.
Yeah.
Because it hasn't set up any of the windows. So actually, it probably should crash.
Yeah.
But that's the best that can happen. Like the worst that can happen is it just fires the missiles or something like that. So, oh, but I lost the. So I want to call. Oh, I lost the thing now. Image.
That's okay.
Render. Screen width. Screen height.
Now we'll see how slow it really is.
Yeah, it's gonna be super fast.
I don't think so. Cool. Hey.
It
That
works.
wasn't so slow.
No, we're doing 20 frames per second. Well, I don't know how many frames per second we're doing. We can draw the what was it? Draw FPS thing.
Okay.
What you give it, something like that. Whoops. Oh, right. So it's withdrawing the FPS and then rendering on top of it. Okay.
Okay. Fair enough.
Oh, 2015. Oh, it's quite bad, I think.
Yeah.
And it also shows up red when it's bad. So
Okay, that's good.
don't know, but it at least runs.
Hmm.
Let's pick a better color. Color.
Well, you can now take a clear background white away.
Yeah, yeah.
We'll be the background, don't worry.
No, it gets slower and slower and slower. Interesting. Oh, but maybe it's timing. Maybe the initial FPS is not accurate.
Yeah.
Maybe it's that we're only doing 5 FPS when we do it like this.
Yeah, but I'm okay with 1 FPS. I'm like,
Yeah, I think it's probably takes a while to settle down.
I also think
Okay.
5 is the minimum for some reason.
Do you think it's doing well? I mean, it drew blue.
Yeah.
What more do you want? Okay.
All right, that's pretty cool.
So what I want to know is why I can't
Yeah.
use the fancy constructor for this.
I think it's because it's an inductive type. I think it needs to be, maybe it needs to be a structure.
It
is
is
a structure.
structure.
No, I don't know. That's a good question.
Come on.
Maybe it needs to be an inductive type.
But this is my vector 2. I can use it for vector 2. It's a pair. This deriving inhabited is irrelevant. Then, or maybe you can't infer the type. Maybe that's it. So maybe I need to. Well, let me just try again. Sorry, this is like. Oh, it works. Okay.
Okay. Sanity restored. Okay.
That would have made no sense to me whatsoever.
No.
Okay, at least. So we have floats, ints, and rationals in this thing now. Although it looks like you can just use. There must be like some type class for rational, which means you can just use integers.
Yeah.
We probably should use that same type class for the vector, so I can just use integers there. Anyway.
How about now we try to draw a transparent image?
Yeah.
Slightly transparent image.
So how should I
just gonna pick a different color. Yeah. We're gonna do exactly the same thing. We're just
well, I mean, like this. I don't want to write RayLean.image. I want to like qualify it. But I don't want to open RayLean.image because this render will conflict. So, well, it's like another meta question of how you manage these namespaces.
Yeah, I don't.
Because I'd like to say like open, like in my Haskell brain, I would like import RayLean.image qualified as I or something like that, just to disambiguate it.
Yeah.
Was this what you wanted me to do? Draw transparent?
Well, okay, let's start with that.
Yeah.
I wanted something slightly transparent.
Ooh.
This is still cool.
It does something because there's no background color, so I think it's like messed up.
Yeah, I like it. Okay, this is actually very useful to draw FPS.
Actually, isn't it because you're drawing something transparent and then you're drawing over it that it's actually not clearing?
Yeah, exactly.
I see. Okay, so it works.
Oh,
it works. Yeah.
So it works
very
because
well.
You're not actually clearing anything. You're just
We're just drawing on top of it. Okay, nice.
That's so cool.
But why was it like processing?
Hmm?
Wasn't it processing? Like it's not drawing on the same point. Are we like hitting some like?
That's the FPS, right? Because it's like the numbers aren't the same length. They're not mono.
Yeah, that's true. I'm with you now.
Yeah.
But it's like, I don't know. Yeah. Anyway. Okay.
So I wanted to draw something slightly transparent. So.
I see what you mean.
Basically,
how do I do that?
Let's construct blue. Yeah. Copy one of these.
Yeah.
Copy one of these lines, and then we play with it.
I want to be
bluish.
Yuck! Did I really pick that formatting? I didn't realize I was the person who did that.
It's okay. Let's say that's bluish, and then
bluish. Yeah.
We play with alpha. Yeah.
Oh. Yeah, it's just drawing more and more blue on top of it.
Okay, it's becoming bluer.
Yeah.
Okay.
Nice.
Fair enough. Okay, and now right after this, like let's draw reddish.
Yeah, let's draw reddish. Okay. What is red in? Was it?
Yeah, so it's the
Don't have X for
255 on the other one.
Hopefully I copy pasted this from somewhere. What should we say 50, 60, 50 something?
Yeah, yeah. I think, but like the whole line, yeah.
Radish.
Yeah.
Nice.
Cool. Okay. Well,
Purple.
we're mixing. Okay. Now we can maybe update our
Oops.
blendy function.
Yeah, blendy.
So I'll send the link to the chat. So I found this like just Stack Overflow link that I sent to the Twitch chat. So it's okay to open on stream.
Okay. Ooh.
Well, depending on if they have ads or whatever. But...
Oh, the Twitch chat. Sorry.
Yeah. So there's just a formula that we can copy.
Fantastic.
Yeah, it does a lot of explaining, but then if you just go to the
Give me the
answer,
formula.
there's the formula. Okay.
Okay. Go and read that at your leisure.
Yes.
Okay, so we need to do this.
Yeah. So CA is color A. So that would be like red for image 1.
Yes.
Multiplied by alpha for image 1. Multiplied by 1 minus alpha for image B. Plus red for image 2 times the alpha for image 2. And then you do that for blue and you do that for green. And
oh, I see. So we have to do this for each of the components.
Yeah.
Okay.
So we can have a little, I don't know, blend float
yeah,
function, but
it goes R, E, D.
Oh, I would just do it for one float.
Oh, sorry.
Yeah, C.
Oh, yeah.
Oh, C1, A1, C2, A2, I guess.
Oh, right. A1?
Actually, since A1 and A2 are going to be the same, you can just, right?
No, A1 and A2 will be different.
But A1 will always be the alpha channel of the first one, and A2 will always be the alpha channel of the second. It's just that you change C's to be red, green, and blue, right?
Yeah.
So, like, what I'm thinking is that actually like, when you apply this formula multiple times, the thing you're changing is C, not really, well,
Yes.
I think.
No, you're right. You're right. But like we're still
Not for alpha, but yeah.
We can do a closure, but like at the end of the day, we still need to pass 4 parameters to execute one of these. So what is confusing, and maybe what is confusing here as well, that A1 and A2 are colors, where I just meant them to be floats.
I'll just bring it out here for a minute.
Yeah.
So this is the color component.
Yes.
of each, and then we've got the
Yeah.
alpha component of each.
Yes.
What we're saying.
Yeah.
Uh,
Because you have to have these 4 parameters
sure.
to
So multiply A1, multiply by 1 minus A2
yeah.
plus E2 times A2.
Yeah.
And then we make a color
Yeah.
with all. Right. Why is it called A? Oh, because it's alpha, I guess.
Mm.
Yes, yes. Red, green, blue.
We could actually take advantage to name it alpha and not just A.
Mm.
Yes.
Yeah.
Not that it's makes sense, but just that
Oh, it would
we
be
have
nice.
that power, I guess.
It would be pretty nice.
Because I was really like RGBA, and then what is A? Aquamarine. I don't want to rename. I don't want to We don't have any like nice tooling
don't
for renaming this. Yeah.
No, but we
Yeah.
can rename at least our blend float function. We can rename.
Yeah. Okay. So alpha, alpha, alpha. And this should be C1, C2 colors. Called A for some reason. Oh, because they were alphas here. Yeah. But not that kind of alpha.
Oh, yeah.
There are alphas. No, we should name it alpha.
No.
They should be called alpha. We should use the Greek letter alpha here. Just...
Oh no. No, please no.
Okay, so I need to
C1.r. Yeah. C2.r.
Okay, and then
C1.a. C2.a.
yeah. Then I do
Cool.
this as well.
Hmm.
G, O, B, G. Ooh.
Oh, that says no. Whoa. No.
What?
Those are A's.
Oh, sorry.
Yeah. So you just
These
have one
sorry,
R left. Yeah. That's a B.
B,
And that's a
B.
B. Yeah, cool. And
I
then we
just
have
not really
one
know what
more.
I'm talking about.
We have one more
Doesn't really-
parameter. No, because we're not done. We still have alpha.
Oh, yeah.
Actually, I think you can implement alpha if you do blend float, but with 1-1.
Ah,
The formula fits
You're right.
1. What should I use? 1, 1.
1-1 and then C1.a and C2.a.
Yeah,
Thank you.
nice. And a comma, and the colon
here?
color doesn't go there. Okay, what's wrong? I can't see the arrow.
Oh,
Blend floats.
are they integers and not floats, perhaps?
Yes.
Oh,
No.
okay, but this is good. Yeah, that's very good because now we can actually prove things about them. Where if they were floats, we were kind of screwed. So
Well, the
okay.
uint8, this is going to work. Because remember, didn't we have a problem with uint8s?
Yes, we did.
Time
But
before last, yeah.
floats would be worse.
Yeah, floats would be worse.
Yeah, we still have a
Floats are
problem.
always worse.
Yeah.
Okay, so we're not blending anything. So now we can try and blend the bouncing ball.
Yeah. So now instead of our monochrome, Well,
Oh, that's a good point. So
we still
what
need
do we
to,
do?
yeah,
We need to blend. We need two images, right? That we blend together.
yeah. So we have bluish and reddish, which we're gonna blend. Like that's it.
Yes.
So you just delete the second render, but you keep
Yeah,
the
and then
image
here.
line. Yeah, exactly.
And then I need to sort this.
I'm okay with it. I don't
Okay.
have a problem with this, like at all. Like I'm weird, but
Okay.
I really like my fully qualified names. I mean, you could spice it better. Like I have a problem with this, but
Yeah, we don't have a formatter, do we?
no. But
Somebody needs to write a formatter.
I'm here, don't worry. I'll format for you. Or just critique your formatting.
Yeah.
Okay, that should work. I guess it should get purplish now.
Yeah.
Hmm.
Not quite. So did I just screw up this probably?
I don't think so. It's RGB. I was gonna double check this alpha formula. Like it's
I get the more.
no, it is right.
Okay, so is this right?
Hmm. How for just for a little experiment, how about we make alpha 1 when we blend? Just turn it into 1 just to see what happens. So instead
Make
of
alpha
blend
one.
float, yeah, instead of blend float 1 C1 A C2 A, just make it comment that line because it looks really correct, but
You want me to put one here?
yeah,
Actually,
just as a little taste.
I think I know what may have been happening. Like uint
Mhm.
8, I think we're treating it as if they were floats between 0 and 1, but actually they're
Yeah.
integers between 0 and 255.
Yes.
I see, because in the formula you have the 1
Correct.
minus and like
Exactly.
multiplication is overflowing probably.
Yeah. It's not a good idea. Yes.
Ah,
So we might need to tweak the formula after all.
okay.
Yeah,
Okay.
because this goes from 0 to 255. Yeah,
Okay,
so
but
we need to do
those ones are still correct. I think you can remove the 1 and bring back the blend float.
yeah.
Like, and then should that 1 in the blend float formula just be 255?
Potentially, yes. But then we have the problem. We do have a problem of overflow as well. But
I think C1 and C2 can remain as integers from 0 to 255, but the alphas do need to be floats.
because it's like normalized, they need to be normalized, right?
Yeah.
So they need to be divided by something that looks a bit like 255, but could be 256.
Yeah, it could be 256. Yeah,
Yeah.
256.
Off by one. Here we go.
Yeah.
I don't even know if you can do this. Well, I mean, this is going to look. Let's see if this looks sort of right. No, it's 25. It should be 256,
Well,
right?
well now, two should all be 256. And
Yeah.
given what you wrote now,
Yeah.
my 255 needs to be 1. Yeah.
Is that right? Yeah. Yes. Because these are normalized. Yeah.
Yeah. And we can do something better.
Okay. So yeah, it's already giving us a warning about dodgy stuff that we're doing with the uint 8s. Yeah. Okay. Yeah. Oh, that's in the C code that's generated. So it's actually a warning from the C code.
Whoa.
That we're doing like you're doing dodgy stuff.
Mm.
I think I hear Discord going. Is someone trying to help us?
I think someone joined and I sent a message
Oh,
saying
okay,
hi.
okay.
Also, you know it's real when it's C that it's letting you know
Yeah.
that something's funny.
Okay, so so the reason that we're using uint8s here is because of the FFI. So maybe we shouldn't use uint8s here. Maybe we should just use ints. Would that make life easier?
I don't know. Like
I think when I did this, it was like, oh, I only need to use a uint8 and I can save some bytes, which is just always the wrong thing to do. So
I don't know. I don't know. So I think Keegan sent on a link that he might want to talk about.
I don't know if it's the correct thing.
Sorry, I just joined using.
hello.
Welcome.
Hello, I just joined using Zoom because previously I was watching on Twitch. I think on the fourth line you need to write 255 255. Fourth line of blend float.
Yes.
Ah, yes.
And I guess the fourth line where you say blend float instead of
Line
one
32.
should be
Yeah.
255. Also, the division I think should be divided by 255 on top.
Okay.
I think.
Let's try.
Because otherwise you would
because
be devising by 0.
Yes.
Yeah.
And you might need
Yes.
to put a 0.0 or something. I don't know if lean. I'm not a lean coder. Like,
Yeah.
I don't know if it kind of chops it.
I see
No.
what you mean.
I think it's not that smart.
No, these are uint8s.
Yes, I think they will just go, if they're less than 255, they will just be 0. That's my suspicion, which they all should just go to 0. And I think that's why it's so dark. Right? It's slow, like there's some small number, but like
Yeah, I think it's because it's division of a uint by a uint. So alpha divided by 255 will be always kind of 0 most times. So you need to first convert alpha when you divide before division. Just there, you need to just convert to float first and then divide.
Okay. Let's try that.
And then the left one.
Oh.
it's not really that easy.
What? Why can't we do that? So I can get a nat. I can get a float out of that.
Okay.
Well, okay. So how do we deal with this? The fact that we need to get a uint8 out of it. So I convert it back to uint8. This is all.
Why don't you, instead of having the 1, you just make it 255? Instead of dividing by 255. Yeah.
Yeah. Okay. That I think that would make sense.
Oh yeah, and at the very end, you kind of divide or multiply, whatever.
Just
so you just divide once.
Walter, maybe have a look at the link I sent. There seems to be a formula there that uses, uint8s.
They still divide by 255 here.
Yeah, but it looks like it makes a bit more sense than.
Yeah, but I think we first have to figure out how to divide by 255 so that it doesn't become 0, right?
Yeah.
Right. So if I look,
but then yeah, we can totally apply what is here, but in the link, but
yeah, I think the link is more or less the same that we're doing. It's just that it's blending 2 full colors with an alpha value, and in our case, one of the colors we're blending also has an alpha value. That's why we have this extra alpha.
Yeah.
Okay.
This is complicated.
So something,
okay.
yeah, this was not supposed to be hard, but like, so what would like be ideal here, right? Well, what is the ideal color representation? It is the well, the alpha, right, is ideally something between 0 and 1. Right? That's kind of what it really needs to be. And so if we want to prove anything, then that needs to be a rational and not a float, right? But before we send it off to RayLean, it needs to be a uint, okay?
Yes.
But it should be pretty easy to convert from rational to uint. And then I feel like because that's a rational, to run this formula on anything, the RGB values also need to be rationals, even if they're between 0 and 255, we can decide, but because we have this formula, like at the end of, we're going to multiply with a rational, so they need to be rational as well. So I would say the ideal color for us is 4 rationals.
Mm.
And then we can blend, and then we can prove things, and
the rationals would be between 0 and 1?
Well, we can decide if they're between 0 and 1 and 0 and 255, but alpha is definitely 0 and 1.
Yeah. Okay.
So it's okay. Okay, so we just define our own color in this image library. We're not going to redefine this for every game now. That's crazy. Okay.
So we put a new color type here inside of this namespace, which this guy's going to use.
Yes.
So.
And then in our render function, only there do we convert between the two.
Yeah.
Okay, so
I think I'd love to write his color here, but what I also would love to write is hiding color. But I can't do that.
Yeah.
Because I want to use vector.
Yeah, you can still use vector. You can just say
RayLean.types.vector.
And then you just say def vector2 is.
Oh, that's true, yeah. Or abrev.
Abrev, that's it. And you go, finally, good use case.
Yeah. Okay, great. And then we can have our own color.
Yeah.
And you want to, should we say red, green, blue?
Yeah, why not? Why not? Let's go all out.
Alpha. Fantastic.
Cool.
Right, and everything's going to work apart from we don't have transparent, so we just need transparent.
Yeah.
Is there a reason?
Transparent? Yeah.
Is there a reason you use rational rather than float?
Yes. So for when we want to prove things, that two mathematical equations are equal. If we use float, we lose precision, and so then it will be really hard to prove things.
Yeah, I see. Yeah.
Yeah.
So you don't want to use a numerical one. You just Yeah. So and your calculations don't involve like nonlinear, like sine or something like that. It's color. You always multiply and divide only.
Well, let's hope. Let's hope, because you might be right. We might want to use some. Oh, please. Yeah, like we might, and then yeah, I will
we might
stand
be
corrected.
Yeah, because
perhaps
I had a problem of using this real. Does it have real lean? I couldn't. I'm very like beginner in lean.
Don't think it has real in. Oh, it does. Oh no, hold on. I'm not sure.
I'm
'Cause
pretty sure.
real is in
But it
batteries
uses-
has real.
But it uses Cauchy sequence, so you can't actually like use them.
Right. So it's
like the mathematical
yeah.
definition.
is it in
math.
batteries or MATLAB? MATLAB, okay.
Probably method.
So wait, what do you mean
I
you can't
think-
use them?
I mean, it's
So
defined.
they're just like infinite sequences of pairs of
Cauchy.
rationals or something. Sorry, infinite sequences of rationals, which converge to a number.
Oh, okay.
Or
So it's like
repeating-
it's like one definition of the real numbers.
Yeah.
Okay, I'm just gonna.
But how you
pretend
can
like I
compute
knew.
with it, I'm not sure.
I'm gonna pretend like I know what you said.
So you have
Cool.
like different ones, like the Dedekind cuts as well. They may be more
Yeah.
computable. But yeah, you get into a whole can of worms about how to represent the real
Yeah.
numbers.
It sounds like it. Sounds
If rational is good, then
Yeah, let's go with
For
rational.
now, the rational is a good choice.
For now, but yeah, well, I might be wrong. But
Right. So what am I doing here?
you're defining.
Yeah, I've got a
Is it
typo down here
transparent?
for some
Cool.
reason, and it's mentioning because this draw pixel needs a 255 type, so we need
Yeah.
a function that does that.
Yeah.
And also, I think that renaming R to red and all of those is giving the rest of the errors. Just
Yeah.
a lot
So
of
there's.
noise.
I see what you
Those
mean.
are
Yeah.
easy to fix.
Yeah.
Easy.
So let me just write down the function. So we do need a function from.
You can't just do .raid.
No. I'm sorry. I'm writing a function to RayLean,
Oh, okay.
which takes a color and gives me a.
But then actually about the red, one might argue that we want to have the same way we have a color dot transparent, we might want to have a color dot red.
Oh yeah.
So
Yeah,
then
yeah.
using red.
Oh, I
yeah,
see what you mean.
It's
Oh,
names, but yeah.
Oh, yeah.
So what should I do then? So alpha we can keep as alpha, right? Or is that
Yeah.
controversial?
No, that's not controversial.
Okay.
Yeah.
So I also need to write this function at some point.
Yeah.
In order that I can call it here.
Cool. Nice.
Right. Now we can. Whoops.
So
I don't know what state this was in.
So there's well, inputs and outputs are rationals now. I think we start with that.
Oh yeah. Yeah,
And the A's become alpha.
Yeah.
And then let's look at the formula. Oh, we commented in. Oh, that's good.
These go back to ones, I suppose, or not.
Yeah.
Oh, it depends how we represent. I don't know. And then this formula is. I don't need to do any division here anymore.
No.
I need to put 1.
Yeah. Delete the divisions. And the last division.
Yeah.
And maybe just add a little comment in the color. Just to say that
Oh yeah, sure.
Alpha is between 0 and 1.
Now, in these types of situations, I always get into the dilemma of should this constraint be like part of the type?
Yeah. But
Or
not right now. But
not right now?
absolutely.
Okay.
Yeah.
Yeah.
But definitely, yes.
Because then I've heard of the concept of you want total functions and then proof things in a subset.
Yeah.
So, but it's so tempting.
Yeah, let's just get something on screen again.
That's fair. That's fair.
So 2 RayLean, I think, is the function we want. And then
Yeah.
I think we want a little debate about whether we want, but let's leave that debate for after. So for now, let's just make RGB still between 0 and 255. But yeah, happy to discuss that. So yeah, basically just 2 net those. No, 2 U.
Oh,
Yeah.
This auto completion is failing. Okay, so it doesn't. Yeah. Okay. So yeah, there we go. Yeah, we won't have a. Maybe we have to go via something else. What do we
I think
get?
2 float is fine. Like we're not, this part we don't prove, right? This is the ringer function. So if it's 2
I
float,
need to make
2 U.
2. Yay. Okay.
Yeah, that's fine. Yeah.
Mm. And here we do what?
Yeah, we do multiply by 255.
Multiply.
Yeah.
Yes. Because it's between 0 and 1. Yeah. Alpha, sorry. Doing all that. Yeah, right. And then we can do the. Oh, then we can do the fancy thing. Say dot. Do.
Okay, fine.
Right.
Okay. Cool.
So what does it do now? Bang.
Yeah. So yeah, we need bluish and reddish, and we can now just define them in this library. So just,
Oh yeah, because it's what? Why doesn't it? It compiles here. Oh no, it doesn't. Oh, sorry.
it didn't.
I was confused.
So we can just copy these to the library and then define them.
Oh, sorry, I was in the wrong place. Yeah.
It'll be easier.
Yeah. Yeah. So this one.
Yeah, it's just alpha and make it.
What should I put in as
0 point? Yeah. Yeah, they're also, yeah. Does that work? That looks good.
I need to go back here and then delete the image. Okay, we'll see how you still like your.
Well, so I have a solution for you as well. You just copy this to the library as well.
Oh, come on.
There we go.
Oh,
Remove
it's
the
not working. Oh, sorry. Thank you.
Nice.
Add image.
Yaj. Okay. Okay.
Here we go.
Hey.
0 FPS. What? Oh. There we go.
That's like.
What was he doing at the beginning? Computing.
I guess we know why they use uint8 instead of rat.
Yes.
Exactly. But it works.
Yeah.
Okay. So yeah, we can debate whether we want everything to be between 0 and 1, because with rational we don't lose anything. Right. Like
Yeah.
it's just a net with 255 at the bottom. So if you want that for consistency, we can do that.
Oh, you mean make these between 0 and 1 as well?
Yeah, if we want. Like it's
but when you get your RGB values, it's usually in terms of not in terms of well, it's usually like hex, isn't it? But
yeah.
rather than like percent.
Cool. Okay, let's keep them that way. No one seems
Maybe
to be
keep them this way.
objecting. Cool. All right, and then how about we check whether our blamed, well, we can call it blamed rat now, I guess, which is quite the visual image. But
Yeah.
oh, that's
Blended
bad.
rat. Rat and gnat.
No rats were harmed. So now we can maybe check whether this satisfies this semigroup property, which is, I think, that's the associative one, right?
Oh, so lawful append. Yeah, lawful. Did that exist, or did we find it?
No, we did not find it.
We don't find it. Okay, so we need to write it then.
Yeah, but it's not going to work unless that formula works, right?
Oh, I see.
So I think like the best way is to first test whether this formula would work, because I think that's actually quite interesting. Is this an associative operation? I don't even know. There's minus in there, so oh, it doesn't look good.
It has 4 arguments. Associative.
Yeah. Okay. So on line 42, there's a blamed function.
Yeah.
And it's really about whether that's associative. Yeah. Sorry.
So you want to check whether, well, let's write it.
Yeah.
I think it is, because if you expand the 1 minus alpha, scratch that.
Okay.
Give me a second. No,
Oh,
yeah, right?
C1.
Because you have C1 times alpha plus C2 times alpha 2 minus C1 times alpha 2. No, because then it's not C2.
Yeah, so it's C1 times alpha, times C1 times alpha minus C1 times alpha 2.
Yes, which is not the same as, like, if you permute C1 and C2 and alpha 1 and alpha 2, you don't get the same necessarily. So I assume that from that you can construct a counterexample.
No, okay, no, so not commutative, right? Well, maybe I'm using the wrong words. I forget them.
Oh, wait, are we?
Did you mean
I was
it to be
talking about
this?
commutativity. Oh, no, I'm sorry. You're right.
Am I right? Okay, because
Yes, no.
yes,
I'm wrong.
I had to Google.
Keep going.
Just to be clear, I get very confused with those words.
Me too.
They're very commutative in my brain, which is very incorrect. Yeah. Yeah, but that Paul's got it down. Yeah, that's what we want to know. Yeah, so just like a paint is not commutative.
Just do
But
ring
it is,
and
but
see
it
what
is
happens.
associative. Yeah. Oh, you're just
Oh, we
gonna
don't have it
Almost.
because we don't have mathlib. We are.
Okay.
Oh. Okay.
No, we have omega. No, omega does no use.
Linarith?
Oh, Linarith. Yeah.
Okay. Well, I can't see your proof state, but
Oh, sorry. Yeah.
okay, cool. But that did nothing.
I think
Linarith
we have to
is,
do something to get Linarith.
yeah, it is in. Yeah, I think we
I
really
forget.
do. We really
I
don't
think
want to prove this.
I think it's in mathlib.
It
We
should
don't
be
have
in
mathlib.
mathlib.
Do
Actually,
we
I
want to
think,
import the whole of mathlib for this?
No.
Yes.
I mean,
We're resisting.
what I'm
doing this.
thinking is that Linarith probably also won't work, right? Because we're working on colors. So we would need to prove it on blend rat
Hmm.
and then use that component wise on blend. I don't know.
I think it's kind of, yeah, we unfold a bit, but yeah, we can't like, yeah. There's going to be some useful proof on blend rat that we need, and I don't know what it is, but like, because of this 4 parameters instead of 2 parameter thing. So yeah, well, I understand we don't want to import mathlib for this, but it also feels like resistance is futile. Like,
Well, we've already added batteries. I'm just
mean-
looking up how you do it.
okay.
What's it? Lake file. I need to require mathlib from Git, and then I need to give it the repo. Then I want to pin it because. And let me just get rid of this for a second.
Yeah, no worries.
Because now this requires 14.0 C1. And then what are they? What is mathlib on now? Mathlib is on something probably different, which will be a problem. Oh, it's on RC2. Do you think we'll get away with that?
Yeah.
Because otherwise I need to update batteries as well.
Yeah, I think we'll get away.
Let me get away with this. Okay. Well, yeah, this is a strange way of doing the dependencies, isn't it? Because if you don't update your library, you're going to be way behind. And then how do you integrate? Because you only have one you only have one version of this in your tool chain, and every library says, "Oh, make sure your tool chain matches our tool chain." But if every library does that, then you can't possibly resolve this. Let's see what happens. I need to. You also need to do that, don't you? You need to do lake updates.
Oh.
Otherwise, it doesn't know what you're talking about. What?
There you go. I mean, just like, you have to appreciate where we are. This could be so much worse.
I know it could be. Okay, so I should have run this. No, I have to say update somewhere, don't I? Oh, no, it's saying that. Oh, yeah, okay. Well, I didn't use that, but.
You're fine. You're fine.
Oh, but this is like hanging.
It takes a while.
It just
does
takes
it? Okay.
a while.
All right.
Yeah.
What?
It's fine. I was just on Reddit and reading how people play Baldur's Gate 3 on their Steam Deck at 20 frames per second. And they were asking like, is it better already? Kind of like, and I'm just, you're so spoiled. Yeah, I finished the whole of Baldur's Gate 1 in 15 frames per second. And then like lots of people commented about their setups. And now like sometimes some of these people play the game like at 1 frame a second, and they just really wanted to play the game. It's just wow. So
wow, yeah, that's dedication.
we're in a pretty spoiled place. Okay, just having Lake Update as a thing is great.
Yeah, but I'm confused. I thought, okay, it just killed Emacs, I think. I thought Lake Update just updated a JSON file. I didn't realize it did some more, because it doesn't build anything. I think it just killed Emacs.
I think it's just
Hold on a second.
It takes a while because I think it downloads a lot of things to try to match versions and stuff.
Yeah, it's doing something. Okay.
Yeah, it's only using a full core. Like it's fine. You could be doing Cabal update, like, and we could just
well,
ping the
Cabal would
stream
tell me
right
what it was
there.
doing.
Yeah, some feedback would be nice. Yes, some little log message or two would have been appreciated.
You already have a project. Add these lines to your Lake file. Okay, yes, and then run. Oh,
I'm pretty sure. Yeah. So that just updates your toolchain.
Yeah, which we don't want. This is like unfriendly.
Yeah.
It's
there we go.
tar.
Oh, it's downloading.
Yeah, there we go.
But
it was downloading RC2?
Oh.
What? Okay.
It might.
It's going to force me to use that now, is it?
Yeah. Again, not bad. Like.
Okay, well, it was yeah, I mean, okay. Yeah, okay, so now it's doing the thing where it's downloading the cache, I think, of mathlib 4, so we don't have to build it, which is nice.
That's very nice. Like.
Ooh. Oh, there we go. It updated. Then it put something in my manifest. Okay.
Yeah, did it?
Now let's try and run. There we go. Oh, because I'm not importing it, so it probably won't build. It won't build it, I don't think.
Mm-hmm.
It takes. What are we doing in this file?
Oh,
we're doing some like magic.
The Linareth is there. That's why.
Yeah, Linareth. Does this work? Oh, yeah. So it was okay. Linareth didn't get anywhere, or did it? Let's see.
Oh, but it found it. Holy shit!
I think it's still doing stuff. No.
Unknown tactic.
Linareth was just something. I don't even know if you spell it like that.
I use spell it like that. Yeah. So import. I got the import for you. Mathlib.
Fantastic.
Yeah. .tactic. .capital L. Linareth. Yeah. And that should be it.
There we go. It's in building the whole of mathlib now.
Okay. Still somehow faster than I expected.
Yeah, it's okay.
For me, it took hours. Like
Yeah.
4 or 5 hours.
Yeah, that's more like that's more normal. Yeah. 4 or 5 hours. Wait, that is actually very long. Like, oh, anything over an hour, I would really worry.
Maybe because I was using, I was on cloud on like a console.
Okay.
Like limitations on something, I don't know.
Okay, that makes sense.
I think I needed to like bump the limit of I needed to bump some kind of limit in Git to be able to download MATLAB or also have it running. It's a beast.
It is big. Yeah. But Linareth, it's a good one.
It better work.
Well, it's not gonna. You can't just do Linareth and it's gonna work. We're gonna have to unfold a few things, I think. But
Yeah, and actually, I may have just written it wrong, but I tried on the Lean playground that we have, and it doesn't seem to like work.
Cool.
Cool. Just perhaps not the best thing to share at this point, but
No, that's good to know. Good to know.
there might be some more work to do.
Yeah, there's definitely more work to do. Bolt failed. Oh,
No, it just
no. I disagree.
Oh, here we go again. What? Why is it one? Oh, because it built it in the.
Yeah.
Why is it running npm? This is awful. What?
Oh,
I don't
why?
have npm installed. Why would it
for
run npm?
proof widgets.
It's missing a doc string. Oh, it's okay. It's a warning. They look very red for warnings, don't they?
Yeah. So I think npm is used for proof widgets.
Do we need those?
No.
Okay.
We definitely do not. It's like to have proofs in your, like to have visual proofs in your proof.
Oh, I
file.
see. Right.
So yeah, it's cool, but yeah, we need a smaller version of MATLAB. Like, okay, I see now. Proof widgets is over the line. Like that's
Requiring npm in my build tool chain. No.
yeah. Like it. I understand why you want it in the whole of MATLAB. Like that. I'm kind of sad
Yeah.
to exclude this really cool experience, but also I just want the tactics.
Okay, so
Should be possible to fork MATLAB into a smaller version that just has what we need.
Oh, that's maybe what batteries was meant to be, but I'm not sure.
Yeah, but they missed Linareth. So like what?
Yeah, maybe it's not for that then. Oh, don't tell me I need. Yeah, looks like I need npm.
No. Okay.
No.
Okay. No.
Oh, hold on a second. Oh, no, it's going to read.
Yeah, because it failed.
Oh no.
Yeah, that's not
Right,
good
surely it doesn't
experience.
need to get mathlib again. Oh.
Yeah, this is not good.
All right. Okay. So I'm meant to use the cache, right? But right. There probably isn't a cache available because I'm using head commit. There probably isn't a cache.
Okay.
So if I use like some other thing, maybe there's a cache. Because these red X's probably mean cache. Oh no, that. Yeah. Well, I mean, the documentation just says use head, so
Yeah.
why wouldn't it work? Oh, is it working now? Oh no. Okay, so I think it's just going to keep rebuilding until I install npm.
Maybe
Which-
you can use release instead of tags. They are probably more stable.
Right, I see. Yeah. Let's see. Yeah, so they don't seem to have. Well, let's try like one from a few days ago.
Now on top, there's releases on top left. Yeah.
Ah, yeah.
Oh, okay. It doesn't have.
Yeah, so I think
It was,
yeah,
it was
I
a
think-
good shot. It was a good try.
Yeah, I think maybe if we may have more luck with a nightly testing. Let's pick one from a few days ago. Let's see what. Probably one that has a. Oh, but it's using nightly. Yeah, okay. It's testing against nightly. It also doesn't seem like a great choice because these might be ahead of. Oh, I don't know.
I think I'm gonna fork Mathlib. I think.
No, I think I've got to install npm. I think I've got.
I usually use NVM, which can
But it's
pull
trying to
any.
invoke him. Oh, NVM does what? Sorry.
NVM is not for now because for video, but in general, NVM is better to use NPM via NVM. So NVM pulls your any version of NPM that you want.
Okay.
Yeah, but it's probably better idea to use homebrew.
Oh my god.
Why is it doing? What the hell is npm needs QEMU? What?
I'm telling you, it's not such a bad idea. We're not gonna do it on stream, but like, it seems like not a bad idea to fork Mathlib and not touch any code, right?
Yeah.
It's only you just delete certain folders and the one file with all the folder names in them, you just update that one file. And you don't touch anything else, and you just keep pulling updates for those folders. So you get all your mathematical tactics that you want, and nothing more.
Or maybe you can maybe there is a kind of exclude from build option somewhere. So instead of like physically deleting them.
Yeah, it would be good, but
Yeah. So maybe you can build
actually,
Mathlib already like that. Clean options.
Does it have the word exclude anywhere?
Yes, I think maybe you can tweak this with options. Let me just show. Like for RayLean, we just to find out what the syntax is. Yeah, so it's like get config. So you can like pass an external config flag. Maybe you can do that here. No, we're not using that mechanism.
Yeah, that would be very
Lean
cool.
options though. Oh, maybe it's this. Lean options. All server args. Oh, I don't know.
No, it's not that. It's just that's just the linker options.
Yeah. going to work this time.
What should it be called? Tiny Mathlib? Mathlibby?
Mathlibby. Okay. It's now running Linarith.
Oh, I got it. I got it. I got it. MathLab. There it is.
MethLab.
Okay. Oh, it's compiling. Okay, sorry.
It's running Linarith now. Remove this.
Oh, I see.
Yeah, it's just taking a long time.
That's good.
I don't want to stop it now.
No, don't.
Oh, but that means the build will fail, right? So, because this is not going to succeed.
Oh, yeah, you might as well.
So if it fails, yeah.
What is happening in your proof mode?
Oh no.
There we go.
Oh,
But this compile will succeed.
Oh yeah, won't it? Where does it do its build then? That's interesting. So it does its build somewhere separately. Blog post on alpha compositing.
That's unrelated, not for this moment exactly, but I've read a previous blog post by the author, and it was wonderful. It was like a blog post explaining how a clock works, and he had like 3D models and like animations. And this is like earlier work, but probably a nice, cool read, and it seems to be talking about this basically.
Cool.
Great, thank you.
Yeah. Very nice. Oh, so close.
I really feel like I've used Mathlib before and not had to do this. I think if the cache works,
yeah, no, it's new.
You're good. Yeah,
it's definitely new. Yeah.
Okay, so Mathlib also has rat in it.
Mm.
At least when it's building, you sort of get an overview of Mathlib. Oh, it has that in it. As the names fly by. Okay, fantastic.
Okay.
It failed.
To find a contradiction. So I guess it succeeded.
What? Yeah, I don't. Maybe it fails, but then it tries to find. Why is it saying false?
Yeah.
Or maybe what it does is if it can't prove it, it tries to give you a contradiction, and then it couldn't find one either.
It could also be that it's trying to prove that this implies false is false by contradiction.
Oh.
So like try to find a contradiction for not what you're trying to have.
Interesting.
Okay, but we can start by unfolding blind, I think.
Yeah. Yeah.
Nice.
Oh, this sucks. What? I mean, Lenarith?
Yeah, let's try it. Can you do that?
No. Okay.
You don't.
I mean, actually,
Yeah.
I think in most of these curly braces, so you have this, for example, right now, B or yeah, R, this component, and then you have like blend rat and other curly braces. At the end of those curly braces, there must be like a .r, right? So you can actually simplify. Actually, you can you run simplify and see what happens?
Yeah.
Does it automatically recognize one as a rat?
I believe so, yeah. Because it wouldn't type check otherwise. But yeah, because this must have some type class, like from
Offnet.
Yeah, offnet. There we go. Yeah.
Yep. Here it is. Sharing it on
Twitch chat. Okay. So now we have these sums. Okay, it's a crazy one, but like unfold blind rat.
Yes.
Lenarith.
Linarith.
No.
What are these other ones? There's Linarith exclamation mark.
Oh.
Really Linarith. What that is.
Okay, sump instead of Lenarith.
Yeah.
Yeah. Oh, yeah, it is associative. So you can see clearly that no.
proof by intimidation.
Oh, that's a good one.
Well, you can do construct, right? Because there's a bunch of ands.
Oh, there's a bunch of ands. Yes.
Yes. Constructor.
I think.
I can't see the whole equation, so I'm not sure.
Yeah, okay.
Yeah, that's okay.
No,
now we just
no,
have to look at one case. That's
yeah. So try Lenarith on that bad boy.
Oh, yeah. Yeah, that's a good idea.
How do I do?
Nope.
Is that the? Do I need to do anything to say I'm in? Does this mean I have two goals?
Yeah,
this interacts with the first one.
Yeah. Yeah.
Okay.
Yeah.
You can do /dot if you want, but
maybe it isn't. Maybe it is not associative.
yeah, it's very possible.
Yeah.
Can we give a simpler formula, like simplify the formula, just maybe C1 times alpha? I don't know.
You can try simple.
Right, just to try.
Oh.
And then it will presumably work.
Oh, okay. I see.
Cool. Maybe I screwed up the definition of...
Just set the definition of the blend rat to just 0. Let's see if it works.
Yeah. Good.
Yeah, because I think this would also work, but I'm not as sure as 0.
Everything's been accomplished.
Yeah.
Okay, well, yeah, okay. And so what is the... sorry. Did you type something in somewhere?
No.
Oh, okay. So if I go back to, what's it, the C1 times...
Yeah.
Maybe this was just, we'd already...
Oh. Even that's hard. Oh, what, do a constructor, just...
Yeah. Yeah, well, I guess we don't know anything about these.
Hmm.
Sorry.
So I just implemented it and I just tried 2 examples and it wasn't associative.
Okay, that's
but
another way to do it.
I could have implemented it wrong. So maybe let's just try, you know, an example, and then we just use a file to just check.
Yeah, that's a good idea.
With your implementation. I might have made a mistake somewhere.
Yeah, so we can do
Let me just check if my thing's correct.
yeah, so we can take that the left side of the formula and then just enter bluish, reddish, and transparent.
Oh, this side. I see.
No. On line 53, the left side.
Ah, okay. I should...
This blend C1, blend C2, blend C3. That. So we just execute that and print the value, the color.
Execute this with
hashtag eval.
All right.
No. Yeah, but not that.
You want me to call this with colors? Oh, okay.
I mean, I suppose you could just change it to it.
But I would just call blend C1, C2, C3.
You want me to substitute colors for the C1, C2, C3?
Yeah, so use bluish, reddish, and transparent. Yeah. We have those.
Yeah, they're not cool.
But write it like you, wrote the like so. Blend bluish, bracket blend reddish.
Oh, I see what you mean. Ah, you mean this one here?
Yeah.
When you said left-hand side, I thought you meant this.
Yeah, sorry, I didn't know how to. I forgot about my drawing tool.
Oh, we got the drawing tool, yes.
Yeah.
There we go.
Forgot.
Whoops.
Yeah. And now you just also
do the other way around. Yes.
Yeah.
Yeah. And bluish.
Yeah. Yeah, it's wildly different.
Actually,
this is good.
I have a question regarding this.
Yeah.
I think that could it possibly be that we have actually implemented blending wrong? So not like we followed perfectly the formula, I think, but could it be that the formula itself is wrong? Because and my reasoning is we're using alpha channels twice to compute, like alpha 1 is having an effect twice. Once in the alpha channel And then once every single time we blend rational. So it's like, could it be that perhaps alpha, we could leave it as alpha, and then alpha 2 is the one that we use to blend rationals, and alpha 1 we keep the same? And this inspired in trying to reconcile with the formulas that we shared before. I don't remember the name, and I cannot see it in the participation. Keegan? Yes.
Yes.
Like the link you sent only had one alpha, so it might be that alpha compositing is only defined on RGB, not alpha. And so do you define, like, when you blend two colors, I might be wrong on this. It's just that looking at it, like expanding just on paper, well, you can't see it, but on paper, just expanding the definitions, it seems like because of the 1 minus thing, like there's this asymmetry where the channel 1 value is being carried over. And I don't know. Because then when you are like, the alpha channel is, yeah, I don't know. Just throwing it out there.
No. Yeah.
What will we change here as a suggestion?
What I'm thinking is, what if delete alpha 1 or like set it to 1, and then in the blend function at line 48, just delete that and put c1.alpha. Replace that whole line with c1.alpha.
Okay.
And so then what you're doing is you have two colors, which are RGB and they're alpha channels. And you're saying, well, I am going to interpolate color 1 with color 2's alpha channel, like color 1 and color 2 with color 2's alpha channel, and keep the C1 alpha channel.
Interesting.
I don't feel like this works completely.
Oh, wow.
Because
well, at least it makes it associative.
It makes it associative.
But does it look right?
Run it. Let's see the picture.
With this example anyway, let's
see the picture.
Oh no. Yeah, of course it's gonna have to rebuild everything because this didn't work last time. Okay, so maybe we can try and prove it while it's doing that.
Yeah, we're not going to get that lucky. No, we still need to unfold.
Unfold what?
Blend. And just unfold blend red while we're at it. And sump. And constructor. And then Lenerath.
Dude. What's it called? Wrap. Oh yeah. Whoops. Oh no, it doesn't. No, the equality is here. No, hold on a second. We're missing stuff. Oh no. This right.
Can you try running ring on it?
Yeah.
And let's pray.
Unknown
you might need to import.
I need to import. Yeah.
Yeah, I assume that.
Hopefully
Yeah,
that doesn't
exactly.
cause it to recompile everything.
Oh no. Okay.
Why does what? I think I'm doing something wrong with this importing business with the setup of mathlib.
I don't know.
Oh.
Yeah, I think it only works if you have the cache. Like that's the only way to make this
Yeah.
User friendly.
work user exactly. So I think there isn't a cache available for this particular hash. So if you would, yeah, so I don't think we're using it right in the sense this is not giving it its best chance to shine.
Yeah.
So I think I just need to find a hash basically that is cached, and then it will work nicer.
No, that's fair.
But this is not like once you build it, you share that with the cache so that everyone else has it cached, right?
No.
No. I think there's a special part of the build that.
Oh.
That's my understanding anyway. That there's some like build process or cron job or something that happens. And then if you according to the documentation, there's like something cache get. Mathlib. I'm probably typing mathlib.
It's
if you got me, Walter. Yeah. Yeah. So or maybe I just need to run that. I thought it did that and it told me the cache wasn't available. But maybe I could just do that.
It wasn't available for all.
It's doing stuff. It's doing something.
Okay, but we could also work more on this next time.
Yeah, I think.
Or do you guys want to continue?
I want to see what happens with ring. Oh, sorry.
Yeah. Oh no, sorry. What was I going to say? So I think our first formula was based on linear interpolation, and I just read it's not associative or commutative, but apparently there are blending modes that are associative.
Aha.
One of them is called additive blending. Apparently, no idea what that means. I just read it off Stack Overflow. But then I came across a blog post that's only available on the archive, called associative alpha blending, and I don't know. It's just like a lot of stuff. It doesn't look that great, but I'll link it.
Yeah.
But yeah.
The one thing is,
let's see.
Yeah, maybe put that in the Discord because the Zoom chat goes away.
Sure.
And ring normal form. That's kind of useful.
It told me to use that.
Yeah.
I don't know.
Like
this. Is it if I hover over this line, does it mean that I see things after the tactic was applied, or do I have to go to the next line for that?
You have to go to the next line. Next line and tab.
Oh right, okay.
At least that's how I do it. I don't know.
If I see that. I mean, there's some change between these lines, but yeah, he can't figure it out.
Yeah, might not. Yeah, but it looks like this new formula looks associative, but would have been nice. pretty sure it has to be a thing.
Yeah, so maybe we need it.
I suggested a formula on Meetup. I sent on Meetup. I don't know where to send it.
On the Discord is also good, or on the Twitch chat. Like those are the two best.
Yeah, I lost the link. I need to find it again.
Okay. Well, this doesn't a paint. Like, it's just which looks pretty much exactly like the one we have now.
Oh, where does this come from?
This comes from Keegan's blog post.
Isn't that the one that he says that doesn't work though?
I don't know. I didn't read it properly. It looked like it was only using one alpha channel though. I don't know.
Oh, I see. It doesn't. Okay. I don't know.
Oh, is it maybe that, okay. I think it's fixing it not by fixing the formula, but by fixing the definition of color. Is it possibly to fix equality to like, I don't like what like I'm just reading a bit, and it seems like he's redefining what a color is in terms of something, and then he's using this new definition to prove that they're actually correct. But what he's doing then is basically redefining a bit. I don't know. I haven't read it completely, but it could be that this is the correct formula. We just need to formulate differently what two colors being equal means. I don't know. Definitely, I'll give it a read.
That could totally be, right? Because we can.
Yeah.
Yeah.
If it's like, because originally what I was thinking with the alpha thing is that, I mean, RGB are channels and they're actual colors, but alpha is just when you want to, well, blend or combine two things. That's what you use to modulate how much of each channel goes. It's like a filter. So I guess that.
Sorry.
No. That's it.
Yeah, but like an example of two colors that are equal is red with 0 transparency and blue with 0 transparency. These are equal. Like they look exactly the same.
Yeah.
So
you got some like quotient thing going on. These are like equivalence classes of
yes,
colors.
It's pretty interesting that like, we've thought we had this very abstract notion of what an image is, but then we use this concrete type color, and it's like, well, maybe not. Like that's.
Yeah, no, actually, I think it's the same problem, right? It's that it's not a rat like or 0, 1 to the full, because the last component like I don't know, topologically like collapses. So
yeah,
that's kind of cool.
It is. So it has some topology.
Yeah. Well, I mean, I'm reading a book on topology now. That's why I had the
Okay.
Yeah, so you're identifying a whole line of point, a
Yes.
whole line. So maybe we should be doing projective geometry and not affine geometry.
Well, it's good that we have all of MATLAB now to do so.
Yeah, we can. Then we can have a line at infinity and things like this. Be great.
Yeah.
Why not? Okay, do we want to pick this up next time?
Yeah, I think yes, we can read some more about associative combinations of colors.
Yeah. And like if we don't find an associative plane function, then yeah, we just need to figure out something else to do for next time.
Yeah, we can find something else to prove. We're just trying to find stuff to prove. So we just need to construct something that we can prove something about. That's the only requirement.
Yeah.
So if this is, we just assume that this would be one of those things, but maybe it isn't.
I didn't assume. I was just hopeful. I was very hopeful.
Yeah.
Because like this paper is built on this assumption, right?
I mean,
that over C is associative because it's saying an image is a monoid. And so
yeah, but he's not blending the alpha.
Well,
channel.
he's clear.
he's
still transparent.
assuming.
So
I think didn't he assume that transparency was a Boolean?
Yeah.
Like.
Okay.
Yeah, I think we had that. I think that's how we had it. Was like.
Because last time, do you remember we just checked if alpha was 0, and then you just replaced it with the second color.
Yeah.
Yeah, that was just me. That was just me being stupid.
Oh.
I was not looking at the paper.
But wasn't it this over though? The over was.
Yeah. But that's
saying
always
that's
me,
either
like making an approximation so we can move forward. I did not see that in the paper.
Okay.
Right.
Yeah.
But regardless, like linear interpolation is not associative.
Well, I don't agree.
But it's just not. We have a counterexample.
But can I mean, I think morally it should be. Like,
yes.
I get what you mean, but morally it should be, because I don't think that software that is like, I don't know, Photoshop or something is like setting an order for like how to render things. I think they're like pre-caching stuff, and if not, then like, I don't know. I feel like morally it should be. It's just that perhaps what we're referring to is like, perhaps it doesn't result in the same colors of like RGBA, but once it goes into the screen, it's the same thing. I don't know. Like, I guess you could turn an RGBA into an RGB by just multiplying the alpha to RGB, and perhaps what you actually get is that if you blend and then transform into an RGB, then those two things are the same.
Right.
I don't quote me on that, but I feel like it should work something like that.
But that sounds like a good equality as well. Is that true, that you just multiply the alpha?
For like, I just got this from my understanding of what alpha does, which might be wrong. But I feel it makes sense.
If you just have RGB are all 0 and alpha is 0.
Can I say something?
Then,
one intuition and one suggested formula, because I updated my formula and put on Twitch. But later I thought an intuition. Imagine a physical experiment of having two semi-transparent color, is it like translucent, if I use the right word, like one, I don't know, some color, the other one another color, and you put them behind each other and you look at them, and then first of all it's commutative. You can swap them, and I think the color would stay the same. And if you put 3 of them, I don't think it will, then it's a physical thing, so it should be associative, you know what I mean? So you're putting things on top of each other. If we consider that as alpha blending, then it can be associative and commutative, but this might not be the only way. Basically, what I meant was having 2 semi-transparent colored kind of filters and put them on each other, and it will be another. It can be seen as one filter.
Yeah, that's convincing to me.
But I also, not based on that, but based on some other intuition, I put a formula, but I'm not sure if that is correct on Twitch. I first put a wrong one. The second one is a correction. I'm not sure if it's correct. But anyway, it might be not, there might be not enough time for that, but I just sent it.
Thanks. So the right-hand side, you're saying A1, A2 divided by A1 plus A2? Is that A1 times A2?
No, sorry. Yeah, and then there's a comma. I because it was 2 lines. And then A3, which is the resulting alpha, is their multiplication divided by the same thing. I'm not sure about that.
So A3 is A1 times A2?
A3 is the outcome of the combination, the alpha of the outcome. Yeah, it might be not right. I just will just guess.
Okay, so I was going to say with this one here that you have RGB all being 0, and then you have alpha 0.
Oh, okay.
This should be transparent and not just RGB. So if you just multiply the alpha channel by, if they're all 0 here, it would be different. Because we have this special one called transparent where alpha is 0.
Yeah. I don't understand. Sorry.
So if you have R equals 0, G equals 0, and B equals 0, and the alpha is equal to 1.
Yeah.
This is not transparent. That's a big color. But then if you set this to 0, it would be this. We're just thinking about this, the comment about just multiply each of the RGB components by the alpha.
Okay.
So here you would have like alpha equals 1 and alpha equals 0 being the same color. But that's not true.
Yeah. I think it might be true if the background is black.
The background is black or background is transparent?
Black.
Okay.
If the background is black and then you can multiply in alpha, I think.
I see. Okay. Yes.
But I'm not sure. That's just I think that's the case where it might work. Okay, but okay, but you're saying with these, so how with these formulas for the new color and the new alpha, right? You're saying these are associative and commutative? They do look that way.
No.
No?
That's a different kind of line of argument, but the physical thing was different. They may or may not be the same. Yeah, that's different.
Okay.
This is just, I think this is correct. I don't know. This is kind of suggestion based on it being a linear combination and things like that. But it may not be the same phenomenon as a physical one.
Cool. Okay, we're gonna end it. We're gonna end the stream.
Yes.
Yeah, and we're gonna try to see what we can have ready for next time. And
before we go, sorry, I don't have pictures. Sorry, you people are. It's my first time here. Do you use RayLean for or?
I'll end the stream and then we can still have a little chat if you want.
Oh, okay, sure.
Okay. Okay, cool. So just stay on the Zoom. Okay. All right, cool. Bye-bye.
Bye. Thank you.
Bye.